Vitamin B3, also known as niacin, is one of the most quietly essential nutrients in the human diet, performing a staggering array of roles in the body that often go unnoticed in mainstream discussions about health and wellness. While vitamins like B12 and C receive substantial public attention for their links to energy and immunity, niacin works mostly behind the scenes, serving as a foundation for over 400 enzyme reactions in the human body. Its contribution is fundamental, but precisely because it operates so broadly and silently, its true value is often underestimated or simply overlooked. At the heart of niacin's function are two crucial coenzymes, NAD, nicotinamide adenine dinucleotide, and NADP, its phosphate form. These molecules are derived directly from vitamin B3 and are necessary for a vast range of metabolic processes, particularly those that involve oxidation reduction redox reactions. Essentially, every time your body needs to extract energy from carbohydrates, fats, or proteins, which happens constantly, it depends on these coenzymes. This makes niacin indispensable for basic survival. The metabolic machinery in every cell of your body requires NAD and NADP not only to generate ADP, the cellular energy currency, but also to carry out DNA repair, cellular signaling, and antioxidant defense. The importance of these processes can't be overstated. Without sufficient niacin, the body's ability to convert food into usable energy would be severely impaired, potentially leading to systemic fatigue, cognitive issues, and, in extreme cases, pellagra, a once common but now rare disease caused by niacin deficiency. What makes niacin even more intriguing is its dynamic interaction with stress, aging, and neurological health. Recent research has linked optimal NAD+ levels with longevity, showing that these levels tend to decline with age, possibly contributing to cellular aging and decreased resilience. Efforts to restore NAD+ levels, often through niacin supplementation or through its related compounds like nicotinamide riboside or nicotinamide mononucleotide, have become a topic of intense interest in anti-aging science. In this context, niacin is no longer just a vitamin required for metabolism. It is emerging as a potential player in the effort to slow down biological aging and protect against age-related diseases. Despite all this, niacin rarely receives the spotlight it deserves. One reason may be that severe deficiency in the modern diet is uncommon, especially in countries where food fortification is standard. As a result, it doesn't trigger the same urgency or attention as nutrients like vitamin D or iron, which are frequently found to be low in many populations. Another factor may be its reputation at higher doses, which can cause an uncomfortable flushing reaction in some individuals. This side effect, while harmless and even potentially beneficial in certain contexts, has likely deterred wider adoption or casual use of niacin for wellness purposes. Furthermore, when used pharmaceutically to lower cholesterol, niacin has fallen out of favor compared to statins, even though it remains effective at improving lipid profiles and lowering cardiovascular risk when used correctly. Beyond energy metabolism and aging, niacin also has profound impacts on brain health. The brain is one of the most energy-demanding organs, and it relies heavily on continuous NAD+ activity to maintain neuron integrity and communication. There is growing evidence suggesting that niacin supplementation may benefit individuals with neurological conditions, such as Alzheimer's disease, Parkinson's disease, and even depression. While research is still early stage in many of these areas, the theoretical foundation is compelling. Neurons under stress, oxidative damage, or metabolic dysfunction could potentially recover more effectively if NAD+ levels were adequately maintained. Niacin also plays a key role in detoxification and inflammation regulation. NADP, in particular, is involved in producing reducing agents like NADPH, which are used by the liver to neutralize toxins and by immune cells to manage oxidative stress. In this sense, niacin becomes not just a metabolic helper but a cellular protector, defending tissues from the chronic low-grade inflammation that underpins many modern diseases. It serves as a kind of internal buffering system, maintaining equilibrium in the face of environmental insults, poor diet, and emotional stress. Taken together, the picture that emerges is of a vitamin that touches virtually every aspect of human health, from how we generate energy and age to how we protect ourselves from disease and cognitive decline. And yet, in the public imagination, niacin rarely escapes the shadows of its more glamorous counterparts. This oversight is not just a matter of public perception. It reflects a broader tendency in health culture to chase novelty rather than to fully appreciate foundational elements. Niacin's roles may not be as flashy as those associated with trendy supplements or exotic superfoods, but its contributions are deeper, more fundamental, and arguably more impactful. Recognizing niacin's quiet influence offers an important lesson that optimal health is not only about what's missing or broken, but also about sustaining the unseen systems that keep us running day after day. In that sense, niacin is not just a nutrient, it is a quiet engine behind human vitality, quietly powering life from within.